Okay. On your notes sheet. This is an example of a discrete relation. And this is an example of a continuous relation. How many ordered pairs are in this?
Really?
How many?
6.
Okay. How many are in this one?
0.
2.
0. 1.
Oh, there's 0. There's no
1.
Ah! There are an infinite number of coordinates. That's why they're all...
I said that.
Did you?
That makes sense.
Once you think about it. Okay. So, here's the deal. When we talk about a discrete relation, that means there is a finite number of ordered pairs. We can count them. Okay? But a continuous relation is going to have an infinite number of ordered pairs. I don't understand why these two are pronounced differently, but it's finite and infinite. Yeah. Because they trust us most.
I don't believe that.
Why is that? Someone else.
I feel like if they trust us the most, they should put us on the page.
Pretty amazing.
I feel like they should put lightning on board because they're like all the bad guys.
And I'm the most.
And they be causing the trouble.
Okay. All right. And with that, now, because I didn't make you get out your student journal.
Oh, my bad.
Okay? No, I didn't. This was wonderful. Thank you. We did not go over the definition of domain and range, so we're just going to do that right here. Yes, good job. Okay, so the domain are all the inputs of our relation, and the range is all the outputs of our relation. Inputs versus outputs. If we're thinking X versus Y, our inputs are X, our outputs are Y. Okay? Okay. All right. So here's the deal. In examples 1, 2, 3, and 4. Do we have discrete or continuous?
Discrete.
Discrete. You are very quick to point that out. How do you know?
Because it's not discrete-ish and
Okay, so you're right. Truman, help him out.
There's not an infinite amount of numbers.
Okay,
exactly what I
so
was saying.
we can count how many coordinates there are. Okay? Okay, so in example 1, the domain. The domain are all of the inputs. So -2, -1, 9, and 10 would be our domain because those are all of the inputs for this relation. Okay. How many coordinates do we need to write down in our range?
Same amount.
Do we?
Yes.
No.
Yes.
No, because what is their point?
So I don't need to write down 1 2 times. I can just write down 1, 5, and 6.
Wait, do you have to put them in?
Okay.
You have like a target.
I do have a question for you, Wyatt. Is this a function?
No. Yes.
No. There's 2 outputs.
No, because there's 2 of the same.
Every input has 1 output. Okay. If I had, like, if I had 10, 7,
It would
that would not be a function because 10 has 2 different outputs. But all of my inputs have different outputs. My y's can repeat. That's okay.
It's just as long as the X is repeated. So if the X is repeated, it's not a function. That one's just going.
Okay, so let's talk about this one. Okay, so given what you just processed through in your brain, is this a function?
No.
This is not a function. Blue table, you are normally not the problem, but today you are. Okay, this is not a function because 3 has more than 1 output and 4 is more than 1 output. Okay, now our domain. What are our inputs?
3, 4, 5. Wait,
Yeah?
we have to put it in like order.
So you don't have to, but it's gonna be easier. It's organized nicer. It's gonna be easier for me to grade it if it's in order. Okay. Thank you. Our range would be -3, -1, 0, 2, and 4. Is that what?
Wait, does the range have to be in order?
It doesn't, but it's easier.
Wait, but why do we put it in that order?
Because that's where we would see them on a number line.
Smallest to biggest.
Oh. Oh.
Really?
All right. I would like you and your elbow partner to quietly do numbers 3 and 4 together.
You're not slick. Not you. Not
So it sounds like we're done.
everything about you, Truman. Said not everything about
All right. Voices off.
you. Shut your mouth.
In number 3. Ainsley, what's our domain?
1, 2, and 3.
Excellent. Lane, what's our range?
Which one?
Yep. Okay. Alfie, is this a function? Sure is. Lino. In number 4. Lino, what's our domain?
Our domain is 4 and 8.
It is. Ethan, what's our range?
-3. No, I looked at the top one.
I know.
1, 6, and 10.
Whoops, that's not the color I wanted. Okay. And then, Ethan, stop. Okay. McKenna, is this a function?
No.
Who's the problem? 4 is the problem. Okay. Go to the next page. Okay. Now we're going to work with graphs. Make 5. Okay. Now we're going to work with graphs. So what we're going to do is we are going to scan from left to right to figure out what our domain is. Okay? So if I scan from, I start at the left and I go to the right, what's the x value here? -4. And then I keep going, what's this x value? And then this guy. Oh, but this also has an x value of 2. Okay, good to know. And then this guy.
4.
Some of us are struggling with counting.
I thought that it said 6. Where, so that's
Thank you for... Okay. Now, when we are looking at the range, we're going to start at the bottom and we're going to go from bottom to top and figure out where we have y values. So, oh, here's one. What's this y value? -3. And then I'm going to go up. And I hit one right here. What's that y value?
0.
And then I hit one right here. What's that y value? 1. And then I hit this guy at 2. And then I hit this guy at 3.
Wait, I'm confused on how we get that.
Okay. So we got the domain by starting on the left side and going towards the right and writing down all of the x coordinates. So x coordinate of -4, -1, 2, 4. And then for the range,
Which one would come first if they're stacked?
they have the same x coordinate. Okay, now, Autumn, because they have the same x coordinate on these two guys, is this a function? No, okay? When we have a graph, your reason I want it to be all about the vertical line test. So we can say that this fails the vertical line test right there, right? VLT, vertical line test.
I see.
Okay. Okay. I am trying to be very patient. And I know that our schedule is different. I know that we have an assembly very soon. I know that we have a 4-day weekend. But I need you to focus. I am going to give you 2 minutes to write down the domain, range, and function, yes or no, for 6 and 7. Let's go.
That was hilarious, Jonah.
No, Lane. Lane, don't take. No, Lane, don't take. No, this one is positive. Lane, no. It's 4, 4.
-2,
Wait,
0,
what?
3.
I got -2.
I have 5. Alright, there.
-2, 0, 1.
It's a function, Solomon.
Good.
Are you?
It's 4, -2. -2.
Wait, we're supposed to do all of them?
Wait, why was it?
What?
6 and 7. Like it's literally the ones I want you to do. Like I don't know what else to say.
Is that on? You're gonna be on video?
Oh, it failed.
I'm recording right now.
I can't wait to watch this back.
So not only did they get that, but I also got the. Yep.
Can I draw on it? Can I write the answer? Oh, because there's a lot of
Okay. Axton, give me the domain for 6. Good. Okay, Ray, give me the range for number 6.
1 and 4.
Good. All right. Bennett, is this a function? Yeah, it passes the vertical line test. Okay. Ryan, give me the domain for 7.
For 7?
7.
-4, 0, 2, and 3.
Excellent. Tierney, the range for number 7.
-3, 0, 1, 3, and 4.
Good. Everybody, is this a function? No, it fails the vertical line test. Okay. Now, when we have a continuous relation, okay, back the truck up. Okay, if we have a discrete relation, we can simply just list out the x values for the domain and the y values for the range. That's what we just did. But when we have a continuous relation, we don't get to do that, okay? Because there's an infinite number of points. So we're going to have some sort of inequality, or it's going to be all real numbers because everything works, okay? So when we're looking at the domain, we're looking at left to right. Do you notice how in this graph, there is nothing over here? Okay, so we start at x as -1, and we only have graph to the right of -1. Do you see that? Which means x is bigger than or equal to 1. And that's how we would describe the domain. Huh? Okay. We have graph at x is -1, x is not, I keep saying -1. It's just 1. I'm sorry about that. Okay. At x is 1 and to the right. Okay? Now, what about our range? Okay? If we look at our range, this guy keeps going on forever, and this guy keeps going on forever. So we have range that keeps going down, 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 down. We have range that keeps going up, 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 up. So any y value I can find a coordinate for. So we are going to write this, which means all real numbers. You know what? This would help if you just be quiet and you can ask me a question one at a time. Okay?
How did we get all
It's like an R with two backs. Yep.
I've seen it before. I just don't.
So my y values keep getting smaller and smaller and smaller, and they get bigger and bigger and bigger. They don't start or stop anywhere. They just keep going in both
How did we get
directions.
that x is greater than or equal to 1?
Because when I go from left to right, do you see I don't have anything over here?
Yeah.
But I have here and this way.
Well, I thought that would be negative 1, because isn't that in the negative positive?
This
no,
is-
that's in the positive negative.
Yep. Okay.
Oh.
Okay, so look at this right here. Oh, is this a function?
No.
No. Okay, number one. First of all, is it a function?
No, it fails the VLT.
Where?
It fails if you just keep going. Oh.
It does not fail the vertical line test, so we're good. We're not going to say shut up. Okay. Hey, let's go. Do you see with our range, do we have anything down here? Remember, range is our y values. Range is up and down. So I have y's at -3 and so we're going to say y is greater than or equal to -3. Now our domain. If we go from left to right, is there anywhere where we're not going to have graph?
No.
Because it's going to keep on going forever in that direction. Can't reach it. And it's going to keep on going forever in that direction. So we're going to say that our domain is all real numbers.
So whenever we have that, that's like
Okay.
Is it just like an I and an R?
It's like an R with two backs.
She already explained it.
like the PLC.
Maybe you should pay attention.
All right. Is number 2 a function? Okay. Shh. The domain. I always like to look and see if it like starts anywhere. Do we have like a starting? Okay. It starts like right here at x equals -2. And then is our graph bigger or smaller?
Bigger. Bigger.
If we go from left to right, it's to the right of -2. So x is bigger than or equal to -2. What about our range? We have a starting point at
-2.
y values, guys, y values. 3. And are we bigger than 3 or smaller than 3?
Oh.
Poof is right.
That's what I'm saying.
All right. I want to go over here to number 4.
Why does it have an open dot?
What?
Why does it have an open dot?
Why does it have an open dot? Okay. All right. Hey, look. When I look at the domain, do you see how there's nothing to the left over here? We have an open dot at -2, and then we have graph to the right of it. Do you see that? So when we go from left to right, we have an open dot at -2, and then we have graph. So we're going to describe that as x is greater than -2. Why did I not put the line? Because it's an open dot. The line closes the dot. Great. Okay. Now, question, where is our, because this like goes up, right? Where is our lowest point? Okay. Is it an open dot?
Yes.
At -3? No. At -3, we have not an open dot, and it gets...
Is it less than?
Well, is it bigger than -3, or is it smaller? Do you see how it's above? I'm like really dancing up here. Great use of your time. Axon, is this a function?
Yes.
We still have 2 minutes. Take a breath. I want to talk about number 5.
That was Truman Graham.
I know.
Truman Graham.
This is the last one we're going to talk about, true man.
To the principal's office.
Okay. I will keep you after the bell if we don't get through this in time. Then be quiet.
Kayate.
That, you didn't even say it right. Okay. Is this a function?
Yes.
Okay. Domain. So from left to right.
What's yours?
Oh, it's infinite. It goes on forever in both directions. So we're going to write all real numbers. I love math. I get to be excited. Our range.
Just call it.
Our range. I had to lower it because I'm too short. Our range from bottom to top.
It's
It's going on forever in both directions. Hey, stop. We have, sit down. Cayete. Oh! We have